Okay, welcome back to physics. Today, we are going to be working on that negative acceleration part of our model where the car is slowing down and figuring out what is the equation and what data do we need in order to figure that out. So I'm going to share my screen and let's get going. So we are still over in our texting and driving. I'm going to start from there in Canvas and go on down here a little ways because you have completed that constant acceleration. We've done the systems analysis, the initial one. You've done your distraction reaction mini lab. And so now we are into thinking about the model in Desmos. So you're going to go to this time of braking Desmos assignment. All right. And in this assignment, I'm just going to go right over to it. It's going to look like this. Your code is 2CTDL. And I'm going to go back and help you look for that one. Let's see. Let's go back to there. Time of braking in Desmos. So here it is. So your code to get over there, the code in student Desmos is 2CTDL, but there's a hot link here to just bump over there. This is what the introduction looks like. And so now that you're there, this is what it should be. So in your hypothesis, slide number 1, what we've said is that we need to start with some sort of a hypothesis for braking distance. So we're looking here at time on the x-axis, distance the car travels. So there's a green part. The car's just going along. There's no braking, there's no acceleration, there's nothing. It's just the green part. So it's a constant speed. Okay, so we've plotted some data points and it's linear. All right, the orange part is the reaction time. Well, we're not slowing down yet. All we've done is go from looking from our phone to out the window. We see that there's a squirrel in front of us, and it takes a little bit of time here, our reaction time, to get the foot onto the brake pedal. All right, this red part, this is the braking side that we have to figure out what it looks like. Because it's certainly not continuing on in a linear manner because our distance and time, so this is reflecting speed, is going to be changing. And the blue over here, purple, this is when we're stopped. So we know this is going to be horizontal because our distance is not changing. Our slope of the line is 0, which means that the speed is 0. So if the slope of the line is approaching 0 as we slow down, what I'm going to ask you to do is draw a line of what you think this is going to look like. That's your hypothesis. And then write that out. Okay, so that's the first part of it. All right, then slide number 2. In this case, what we thought was, okay, it's going to sort of begin to continue here and it's going to somehow transition to horizontal. And you're going to pick a line. So on our distraction, I've got that is 10. Our reaction, let's see, I'm gonna leave that one. That's 10. And then braking, braking, yeah, it sort of starts there, but then I've got I gotta bend it. And then maybe come back here a little bit. And then maybe go like this. There, I got it. Okay, all lined up. And what that says is, yeah, it's sort of transitioning from constant velocity here to a negative acceleration here to stopped over here. All right. So this acceleration due to braking with a -8, because it is negative. Acceleration is negative because we are slowing down. If there was a positive acceleration, we'd be speeding up. So let's take a look at 3 different models. In this case, we have a little car, a mid-sized car, a little car, sports car, and then we have a big truck. And so which vehicle A, B, or C does each of those represent? Well, This one says that vehicle C, we're able to get that car going from a constant velocity to stopped pretty quick, because that occurs like right about here. If we had our line, our vertical line, if I could move that over again, we could move that over. And the next one, we stop about here. And then last one, vehicle A, it takes a long time to stop. Remember, because time is on our x-axis. So you have to decide which vehicle is which in terms of A, B, and C. All right. So once you've figured those out, which one is A, B, and C, we're going to go back and begin to look at our model, because we need some numbers with that. And we're going to make some predictions. So on this one, slide number 4, we're actually putting the equation in. And if you go, wow, that's crazy big equation, it's really not. Because when we look at these lines are quadratic. And we know from our earlier work on patterns that a quadratic equation is y equals ax squared. So we have a squared value, and we have some sort of coefficient a. All right, so let's look here. Wow, okay, this is y, the distance the sports car travels. And we'll just forget about this 30 times t thing for a second. We have 1/2 times -10. Well, that would be -5. So we have -5 times x squared, -5x squared. Wow, that's just what we always knew. Y equals -5x squared. That's quadratic. But rather than sloping up the way we saw it in our earlier patterns unit, it's sloping to horizontal because a is negative. Now all that we've done is we've added a number, 30 times t. 30 is our starting speed, so 30 times the time. So by adding or subtracting this to our ax squared, all we're doing is moving this line up and down or back and forth. Okay, that's all that's happening with that number. So this really is the same as you've seen before. So let's take this apart again. So the distance the sports car travels is equal to its initial speed times the time. Well, we did that in our model. Speed times time is distance. Okay, so that's the constant part of it, the constant part that's happening right here. Okay, then we're going to add to that our quadratic part, 1/2 times the acceleration rate times the time squared. All right. And so that gives us this form of the line as we're approaching horizontal. So we're going to remember this because we're going to need to take this over to our other model. And in this case, we're going to assume that you're not driving a sports car or a truck. We'll take that mid one of -8 for our acceleration. So we'll have to remember that or come back to that. Screen number 5 gives you a little task to do about another estimation. And then screen 7 gives you the actual equation, which we will need later on. All right, so that is that lab. Make sure that you have that totally done so that we can use that information later in our modeling.